Yeah, we are live and feel free to start.
Oh, okay. Hi guys, welcome to our new hackathon workshop this week. And I'm your host, Lini, as well as my colleague, Wenjia.
Yeah, hi guys, I'm the host of Wenjia.
Okay.
And our topic today, Lini, do you have some idea about our topic today?
I guess it's a time we talk about the decentralized finance on Avalanche. Previously in our workshops, we covered basically a lot of tech stuff about how to build your first application on Avalanche, some useful tools, and as well as the interoperability and the token economics design from the previous workshop. And tonight, I think we are honored to invite one of very, until now, very successful DeFi project on Avalanche, Platypus.
Who is that?
Venom.
Yeah. Thank you, guys. I'm honored to be here.
Okay, so
welcome, very welcome.
I guess you must be very familiar with Platypus, right?
Yeah. We built it. Yeah. So.
Okay, nice. Maybe let's cut the chase, and I gave the stage to Mr. Warner for now. Yeah, please go ahead.
Yeah. So let me share my screen. So you guys can see my screen,
Yeah.
right?
Yes, very clear.
Okay. Let me just. Okay, just making sure. Okay. So this topic I want to talk about today is called the decentralized app architecture. So basically, what I want to share is basically my journey from a Web2 developer to becoming a Web3 developer. So I think, for this workshop, it will be beneficial to you if you are already a Web2 developers and you want to start your journey in Web3, because I will talk about the difference between the Web2 and Web3, and what does it mean to be decentralized, and also the common tech stack of Web3 that we use to build decentralized application. And finally, we'll go through the app demo in React. It will be a front end that interacts with our Platypus smart contract. So let's dive right in. So let me briefly explain in a high level the Web2 versus Web3 the characteristics, right? So in Web2, we know that there's existence of authorities, like different companies. They have their own architecture, they have their own system, fully controlled by them, and it is centralized. So they have full control to censor any content or ban any users, and the whole thing is not permissionless. So that's basically the characteristics of it. And let's look at the pros and cons, right? So the pros is that authority can ban or censor any bad actors. So if you are trying to post some spamming on the system, you will get banned, etc. So this is a good thing, right? Because we make sure the system, we don't have any scammers or anything in there. The second thing is it is easily scalable. We can build we can basically, there's no limitation of computing power. We can use data center level of computing power as long as you can afford it, right? And also the user experience is much better in the Web2 world, because you can get customer support, and you can get because they know who you are, what you have done with the system, so they can better support you. And the cons is that in terms of system architecture, so because everything is like centralized, so there is a single point of failure. For example, your system can be down if the if the data center like AWS has some outage, etc. So that's not a good thing, right? And the second thing is the authority, basically the company. They can decide to ban or censor anyone if they want. And it can be, well, it is both pro and cons, but if they do it in an unfair way, then it is a con, right? And the third thing is that the system can be shut down by the owner at any time. So if they want to shut down completely, they have the ability to do so, and then all the users will lose all of the content or all of their, if they have money in the bank, then it can be shut down by the owner, and it requires a lot of trust on the authority. So that's the Web 2 world that we had. And let's look at some characteristics of the Web 3. So the first thing is in terms of architecture, is decentralized. So we don't have like any centralized company, any like single point of failure, and also we have no censorship, and it can be permissionless. We should not say that it is permissionless, because it depends on how the smart contract is written. It can be permissioned, but it's possible to write smart contract and verify it such that it is permissionless. So that's the characteristics. And we also have like pros and cons of these systems. First is that it has no single points of failure because it's fully decentralized. Second is that the system cannot be shut down by the owner at any time. So we can make sure that of course, I should say it is possible to configure the system in a way that is verifiable. So in the sense that like if the smart contract is perfectly written, then there will be no like rug pulls or like any things malicious thing possible made by even the owner. And of course, there's some cons compared to Web 2 architecture. Is that you cannot ban or censor any bad actors like using our Web 3. So if you have like a decentralized exchange, you cannot censor. Like basically, you cannot restrict anyone from using your exchange. And then you have limited computing power because things are running on the smart contract. And basically, for smart contract, you cannot run a lot of code, right? The code has to be really optimized because it's redundantly running on all of the validator's computer. And the third thing is not easily scalable and decentralized at the same time. And the fourth thing is like the UX is the UI and the UX might be difficult to use, and then it's also difficult to provide really good customer support compared to Web 2. And the last thing is we require users to be fairly educated, right? For example, DeFi, they need to know what is address, what is like public key, private keys, like LP tokens, all this kind of stuff, and what is approvals. So users need to be a little bit like tech savvy to be able to use the system and not be scammed by some scammers. So these are the pros and cons. And let's look at the architecture, right? So in the system architecture, we can see that this is a Web2 traditional architecture. We can see that there's users using the front end interacting with the web servers, and the web servers are not decentralized, right? It's owned by the company, and then reading the database also owned by the company. So the whole thing is centralized. That's a Web2 architecture, and it can be done very scalably and efficiently, right? But then we also have these pictures of Web3 architecture, which is the users will now use the browser to interact with the blockchain. The blockchain, as we know, it is decentralized, right? But then how do the users interact with it? So first thing is that instead of CDN, we can have IPFS that store the content of the front end, and then the users can get the front end from IPFS, and then there's some JSON RPC providers like Infura that users can use to basically interact with the blockchain. So in this arrow right here, users are indirectly interacting with the smart contract. Like either they are querying data from it or sending transaction to the blockchain. Because traditionally, if you want to interact with the blockchain, you need to like run a node to be a validator and then look at the blockchain data, right? So these providers, JSON RPC providers, introduce like some gateways for the users, so they don't have to run a blockchain node, but then they can still read the blockchain data and interact with it. So I know this part it doesn't sound decentralized, right? Because we require Infura or Alchemy, these type of providers. But then if you think about it, there's like, multiple providers. If one of them fail, then we can still use another one. So it's not perfect instead of like in terms of decentralization, but is much better compared to Web2, right? And also we have something called the graph. So the graph is because if you read the smart contract data, we will also look at it later, right, in the demo session. But the idea is that if you read from the smart contract, you can only see the current state of the smart contract, and anything that requires historical data or like transformed data, you will need to use the subgraph to process the data and get back the result you want. And most importantly, the subgraph is also decentralized. So it's not a single centralized company doing it. The whole thing is decentralized. So as you can see, basically all of the connection here, they are done decentralizedly. So that's the Web3 architecture. And when we talk about decentralization, I think there's multiple aspects of it. So let's go through each of the definition, right? So for example, decentralization, if we are talking about the blockchain level, like the underlying blockchain, such as like Ethereum, Avalanche, or like BSC, this type of blockchain, there's a concept called decentralization that measures how many numbers of validators, right? And is it permissionless? And also the requirement of being a validator, is it a high requirement or it's a low requirement? And also the cost of malicious act, we want it to be high such that reverting transactions and spamming the networks is not possible. So the second type of decentralization is the distribution of wealth. So like how the tokens are minted, to whom, and that's basically whether the economics of the system is fair or not. So that's has to do with the tokenomics. But then the third types of decentralization is the in terms of the architecture, is it decentralized? So that's what I want to talk about. So the tech stack and the technical components, we want to make sure it has no downtime and no single point of failure for hackers to attack. So let's look at some of the components. And you can see that these are the services that exist in the Web 2 world. But then we want the Web 3 version, the decentralized version of it. So the first is the static hosting. Traditionally we have AWS CDN, but then files or like content can be shared through a decentralized network, for example, IPFS. So that's basically replacing CDN, right? And the second is a domain name system. Traditionally, we use DNS like GoDaddy, Namecheap. We buy a domain name from them. But then we have something like ENS or Aave that is doing a domain name system in a decentralized fashion. And then we have also data from a traditional database servers like a server running Postgres. Right now we can use Subgraph to process the data and then transform the data and then show the give us back the data that we want. So and then we also have like computing resources. Like back then we have backend servers running like Python or like any Node.js, but then we can switch to smart contracts, like they are done decentralizedly. And then in terms of code, we used to have like a closed source repository, but then in the Web3 world, developers are encouraged to open source their code such that they can, everyone can verify it and everyone can trust it, and so that they can use it safely, right? So as you can see, all these type of Web2 services, they all have a decentralized version. Okay, cool. So let's go to the demo. So let me talk about what I'm going to do in the demo. So we will be building like a very simple D app, but it is able to query data from the smart contract and send transaction to the smart contract, and also use Subgraph to retrieve some data. So I will publish the code to this link. So if you guys are watching the videos, you can go to this repository and you can code along or clone the repository to play around with it. So okay, so let me go to the code. So as you can see, let me do a yarn start so we can see the. Okay, it's running. So let me just. Okay, I think that's better. So this is directly from Create React app. So if you guys want to follow it, you can do, I think, you can do this yarn create create React app and the name of the repository, and then here I use TypeScript. So you will basically get this thing, get this code. You will not get this. I just had it here for the demo. So let me just briefly walk through what I have built in here. So we use a library called Moralis. I think it's pretty good, pretty very user-friendly, developers-friendly library that allows us to connect to the smart contract, connect to users' wallet very easily. So this is basically, it's called React Moralis, so you can look it up. And basically, after you clone the TypeScript, you will have to install these 3 packages. So if you are using Yarn, then you use Yarn add Moralis, React Moralis, and the library called Ethers.js. This is, I think, currently the most popular libraries to interact with a Solidity code. So you will have the Moralis provider here, and then what we have here is a connect wallet button. So if you take a look at the code, because we are using Moralis, we can basically use one single line of code to connect to Web3. So if I refresh the page, and if I click Connect Wallet, you can immediately see my address and also the network that I'm using. So 0xA86A, this one is the Avalanche C chain. So you can see it here. When I click the button, it connects to this like enable Web3 function, and the Moralis library does the rest for you. So that's basically this function. And then the second thing I want to show you is what we have is the display deposits. So the second thing that we want to do is, so right now what we have done, we simply got the address of the user's wallet, right? So when I open my MetaMask, which is the most popular wallet to interact with smart contract or Dapps, I immediately see my address, and now I know my network. But then if you want to interact with a smart contract, for example, this is the Platypus website, right? For example, I want to query some data from Platypus. So, for example, we want to know the pool deposits of Platypus. So how many, the total amount of deposits, of USDC deposits that is currently on Platypus. So what we can do is, first we will need the contract API. Basically, you can get it from Snowtrace Explorer, and you can get the API. Our smart contracts codes are all verified, so you can get the API and also get the address of it. And here I have a call a new contract, and then I put the USDC LP address. And once I get the liability, which is the deposit, by the way. So once I call this function, I can display it on the on here. So you can see USDC deposits. We have 268 million. 268. Oh, I think this is a wrong number. This should be USDC.E, not USDC. So if I want the correct address, just a moment. USDC should be this one. Okay, so we are expecting 182 millions, right? So let me just correct the address and refresh the page, connect wallet, and now we see the same number that is displayed on the Platypus front end. So 182 million, we got this number here. So as you can see, if you are, a Web2 developers, what you would do is to query the back end, right? But now in the Web3 world, there's no back end. Instead, we have smart contract. So here, once you connect to the smart contract, you can simply call the function to get back the data that you want. And as long as you have the address, you have the contract code, then you can basically interact with the contract, right? So that's the first thing I want to show you. The second thing is what we did was, querying data from the smart contract. But the other thing is you can also send transaction to the smart contract. So for example, if I want to swap some tokens, I have USDC, I want to swap it to USDT. What I can do is, if I want to swap 3 USDC, I get back 2.998 USDT, which is let's see. Yeah, which is not a good rate because of the coverage ratio. But if we do this, yeah, we get a much better rate. That's how our protocol works. It wants to balance the coverage ratios. So yeah, so that's the rate we are getting. So if we go to so let me demo it, like how to do it in the code, right? So this is a swap tokens components, which is this part. So we have USDC to USDT, and I can still get the quotation. So if I have 500 USDC, I click the get quote in USDT, you can see I get back 499.7. So let's see how it works, right? So similar to how we display the USDC total volume, total deposits, we are using the same code to first we create a contract, and then second we call the quote function and specify the USDC address, USDT address, and also the amount I typed in. So I type in 500. It's sent to the smart contract. Well, it doesn't actually send to the smart contract because this one is reading from the smart contract, right? It's not a real transaction, but it's able to execute the view function of the smart contract and get back the quotation. And this is just some React code to display it, right? So if you are a Web2 developer familiar with React and front end, then it should be familiar to you. The thing that is new is just in terms of how we call the data. Traditionally you will call API from the backend and call API to view data and send any transaction, but we just replace it with the smart contract code, right? Using the ethers.js library. So let's look at how much USDC I have, right? So I have 86.5 USDC and I have 0 USDT. So if I want to swap 10 USDC, so first I click get quote. It shows that I will get back this amount of USDT, and I think it's a good rate. So I click swap. So before I click swap, let me just go through the code, and you can see that it's very simple. It is calling pool.swap, basically calling the pool contract, and you are telling it that you want to swap from USDC to USDT with this amount. And if I click swap, okay, so let me just make the transaction and make sure and wait for a while. Okay, it's done. So I have successfully swapped. So let's look at how many assets we have. So before that, I had 86.5 USDC, right? After swap, I have 76.5 USDC. And it has been swapped to USDT. So you can see my wallet. I have 9.99581 USDT, exactly the quote that I got from the smart contract earlier, right? So, so this is it. You can see how simple it is to create code to interact with the smart contract, whether you want to connect to the wallet, connect the users from their browser to the smart contract, or get data from the smart contract, or send transactions. So we have covered the first three, right, in the demo. And there's one more thing I want to show you is some of the data on our front end, right? You might be wondering, we are able to get the pool deposits, we are able to get the users' deposits, but things like volume or APRs, these cannot be directly queried from the smart contract, because smart contracts only gives you the current state of the, how much deposit it has, how much liability or assets it has. And this kind of data like volume or APR, it requires historical data. So it is not possible to do it with the smart contract alone. So we require something called subgraph, right? As I mentioned earlier, is able to process all of the transactions and transform the data into something that we need. So for example, if I'm using Platypus exchange, the subgraph, I can play around with it. I can get any deposit or any transactions that I want. So one example here is that I want to query the tokens, right? So you can see we have a few tokens listed on Platypus. And if I click refresh, so I can see the total trade volume, for example, of USDC. So this is a total trade volume from the beginning to this moment. There has been 337 million USDC that was swapped on Platypus. So not bad, right? This number, and we are able to get it from the subgraph, right? So how do we display the 24 hours, the daily volumes, right? So remember subgraph, it allows us to query historical data as well. So we were able to get this number, total volume, from the beginning up till now. This is a number, right? We are also able to get the number 24 hours before. So 24 hours before, it will be from the beginning up to 24 hours before. So when we subtract these two numbers, it gives us the 24 hours volume, right? And this is how we use the subgraph to calculate the 24 hours volume. And we also use similar technique to calculate the APRs, the boosted APRs, etc. So let me go back to the diagram. You have seen, well, it was a very short demo, but you have seen all of the building blocks of Web3 components. You have seen how we use the front end connected to the provider and view transaction, view the smart contract data, and send transaction, and also using the subgraph to get all sorts of data that you want. So yeah, so that's it for the sharing. If you guys have like any questions, you can ask. But yeah, that's it.
Well, yeah. Thank you, Vernon.
I hope I didn't like confuse you guys, but yeah.
No, not at all. It's quite an impressive presentation. Nice
Yeah,
work.
I have changed my background. It's our very good ecosystem project, and I think you are on the top. So how do you think the key reason why you get so success? Can you tell us?
In terms of, I think our project is generating a lot of traction is because we are a brand new protocol. It is not a clone of any. It's not a fork of any other protocols, and we are innovative, and we are solving a lot of issues like for stable swap, we allow single-sided deposits, and we allow very low slippage. So I think that's quite innovative. So yeah.
Okay. So do you think there are any other projects can compare with you?
Well, we will see. Like of course, there are other projects like doing very innovative stuff in the DeFi space, and also in Avalanche as well. There's in the Avalanche ecosystem, there's a lot of innovative projects right now. So it's excited to be in this space.
Cool.
Yeah.
Okay, thank you for your time again, Vernon. Really appreciated your time.
Yeah. Thanks a lot.
Thank you.
Okay, thanks a lot. Take care.
Okay.
Bye.
Take care.
Bye.
Bye.
Bye. So Wenjia, in case I'm but you're kind of confused by this tech, presentation. So React is a JavaScript library for building user interfaces. And the key features for React is declarative, it's component-based. And once you learn the React, it can be written anywhere. So React doesn't make assumptions about the rest of your technology stack. So developers can develop new features in React without rewriting existing code. And also React can also render on server using Node and power mobile apps using the React Native. So the next part, I think, will be, also Wenjia mentioned in his presentation, he used a tool called Moralis. Luckily, the next speaker, we invite Mr. Dmitry from the Moralis labs, which will give a detailed presentation on how to use the Moralis React toolkit to develop Avalanche. So the next one, let's hear what Mr. Dmitry will tell us.
Okay, welcome.
Just let's start from the basics. So React is a JavaScript user interface library created by the Facebook. With React, you can create web applications that change display without reloading the page. This makes your app faster and improves the user experience. Now, about 90% of all front-end developer jobs require React experience. It's also used in almost all Web3 projects. React is a true Web3 front-end standard. One of the key features of React is its versatility. This library can be used on server and Moralis platforms using React Native. So you learn once and you can use it anywhere. React is component-based, which is another key feature of the library. Each component returns a part of the interface and in different states. A declarative approach makes your code shorter and easier for reading it. It makes it easy to test it and maintain. React uses JSX. Let me show the example. Here in Moralis, Web3 React Moralis, we have, as you can see, JSX syntax looks like HTML plus JavaScript. It allows you to write JavaScript code using ready-made components that almost completely duplicate HTML. This makes development easier and faster. Usually in Dapp, you need to display a great number of different information. It constantly changes, updates, recalculates, and you need to display it dynamically. It's hard to achieve the default vanilla JavaScript plus HTML stack. Your code will become unreadable, difficult to maintain, and most likely will have a bad performance. And as I said before, React is a true Web3 standard. Mostly all Web3 projects use it. You can check GitHub's open source Web3 projects, and I guarantee 90% of them use React. The functional approach is very convenient, especially with hooks. So what are these components and hooks? React components are small, reusable pieces of code that return a React element to be rendered to the page. For example, in the examples of the React Moralis, we have here use ERC20 balances. As you can see, here we import the hook use ERC20 balances, and we get the function to call it to fetch the balances, the data which will be returned, the status of fetching, and if we will have any errors, we will get them from the error. So you can see this is a basic HTML code. and we integrate here JavaScript code like this. So what about hooks? For example, use ERC20 balances. Hooks are functions that let you hook into React state and lifecycle features from functional components like we have here. We have component ERC20 balances, which returns ERC20 balances. Yeah. There are a bunch of default React hooks like state, effect, context, and etc. And also you can even create custom hooks, and we have them in the React Moralis library. You can see the list of them here. Yeah, here. So we are with 3 developers. We need nice hooks for interacting with blockchain, with Avalanche blockchain. We want to receive and record the information from it and to it, and we want to get it as fast as possible, right? We need to easily get ERC20 and NFT balances, transactions of wallet addresses, token prices, and be able to get them in all components of our amazing Dapps. And all this you can find here in the React Moralis. So yeah, React Moralis is basically it's wrapper around our Moralis library for JavaScript. So that's why you can get mostly all information you need for it from the default Dapps documentation for Moralis. Yeah. Also, we have here most of them are really frequently used. For example, from the hook use Moralis, you can get function authenticate, which help you to authenticate users while their Web3 wallets, for example, MetaMask. Some of the hooks are used to work with a database that Moralis gives you. For example, use Moralis query, use Moralis file here. This helps you to get information to sort to filter it from the React from the Moralis database. I will show you an example here. So this is a dashboard you get. Yeah, it takes some time. Okay, we'll continue later. So yeah, here we can find here user addresses, their balances, info about sessions, and after a while, when you will have more and more users, the database will be it will become bigger, and it will have also balances, NFT transfers, transactions, and etc. etc. So also we have a Venom boilerplate. You've seen its demo in the beginning. It's made on top of our React Moralis library. This boilerplate will speed up your Avalanche Dapp development because it already has all frequently used Web3 React components and hooks for fast building Dapps without running own backend. Let me show you the list of components and hooks inside it. So you can find the Ethereum boilerplate in GitHub, or just Google it and you will see it because it's on the first place here. So here is a list of ready-made components you can use. For example, a component account. Yeah, it helps you to authenticate your users to your Dapp. Also, for example, yeah, address. It displays addresses with blocky avatars. Also, address input. It allows you to input addresses, for example, for sending tokens. And also it works with crypto domains, like you can see here. For example, the chains component allows you to switch the network and shows you the current one. So also you can see here the list of Ethereum hooks, but almost all of them are part of the React Moralis library. And this is not the only boilerplate we have, actually. Also, we have boilerplate. Let me show boilerplate social network for NFT marketplace. Yeah. And even for Unity, yeah, here. But the workshop for Unity will be in 2 days later. So yeah. Okay, so now let's try to download, to clone this boilerplate and run it locally, step by step. So all we need is to go here to the Ethereum boilerplate repository. Here you will find the link. You can easily clone it. And now I should switch to the IDE, to the Visual Studio Code. And now switch to the IDE, to the Visual Studio Code. Share screen. Okay, here. Share screen. Okay, I see. It works. So now all we need is to run git clone and input here our link we cloned from the repository, like this. I just press Ctrl plus V, like this, and press enter, and the boilerplate will be downloaded to your computer. Then after this, we need to go to the downloaded folder, like this CD Ethereum boilerplate. Now we need to install all dependencies. You can easily do it by yarn install, like this, or npm install. I will not run this command because I already have installed dependencies and the boilerplate. So the next step, we need to provide the information to .env.example, as you can see here. So we need to add here Moralis application ID and Moralis server URL. You can find them in your server details. So I will just copy and paste. I have them already. So like this. And after that, you need to rename the file to the .env. And now we will run our application like this, yarn start. it takes a while. Could you help me, please? Move from stream. Yeah, here we go. Thank you. So now we can see our application. It's already running. Here we can see the quick start tab. It's a nice reminder and helper for you when you can forget something. So yeah, let's switch to the second one. It's a wallet component I already showed you in the demo. So as you can see here, we can clone our address and input it here, for example, like this. Yeah. And as you can see, it automatically validates your address. When it's correct, it just will not give us a permission to edit it, but we can easily change it. And also it supports crypto domains. For example, domain crypto, or no, bread crypto. Yeah, is fiat component, which gives you an opportunity to buy crypto using your credit card, and it's already integrated to your application. So here we can select even chain and a lot of different assets and buy them for your cash using your credit card. Also, we have component balances. That is a nice table, and it shows our balance and address of tokens, our transfers and NFTs. I guess we should switch to another network. For example, let's switch to the Colon testnet. Linkable. Yeah, here we go. These NFTs are stored on centralized server. That's why it takes a while really to get the images, but usually it's instantly. You will get the pictures like instantly. So you can see here information. You can open the information blockchain explorers. Also, you can transfer them or even sell them on OpenSea. We actually have the add-on for this boilerplate, but I'm not sure if it's yeah, it's still not added here. So also we have a nice component which will be really useful for you when you are working on own contract. So you can add it to the application, run it, because the boilerplate it supports the Ganesh localhost, and after 2 commands you will see the interface of your contract right here in the application. So let's try to delete this one quick start because we don't need it on our project. So we need to go here. Give me a second, please. Stop screen. Thank you. So we can open our app.js6 file. And here we have roles. So let's delete this one. Inside the app.js6, we have a router, which allows us to switch between different pages of our application. And it, as you can see here, each component has own address. Okay, so let's remove it also from the header. We have it menu items. Yeah, let's remove it here.
Yeah, perfect. Let's see. Also, your MetaMask started to pop up, so that was good. Was it some kind of setting in MetaMask? Because in the beginning we couldn't see it, but now we could see it when you shared your screen.
I've changed the streaming. Previously, it was just showing the my
window,
my browser, but now I share the full my screen. So yeah, that's why you can see it right now.
Yeah, a question about how long does it last in IPFS? Yeah, it needs to be pinned. And if you have a pro account, we will pin it as long as you have a pro account. And soon we will also add more integrations with third-party providers like Pinata and even Infura. So you can have your own like external IPFS connection to us. But yeah, as long as you have a pro account, we will pin it. Putting and connecting another contract in there. Yeah, this is what we tried, but it was some issue with the local dev chain that on the screen. But in a few days, you can enter any contract address and it will show up. Yeah, good questions that we've had on this one. Can't wait to grind some React projects. Yes, this is maybe the most important knowledge in crypto, to know React. Can I just remove the HTML or route as well? You can do what you want. I mean, you can create new routes. You can remove routes. You need to define still the route you need, but you can do whatever you want in terms of the in terms of the routing and how the files are structured. If you have any questions, guys, by the way, go to the forum, and Dmitry can also help you there with your specific case. So Dmitry, if we show the forum there, and we show the Ethereum React boilerplate, this one. So go to the forum, forum.moralis.io, and if you search Ethereum boilerplate questions, you can ask Dmitry there, and he will answer you with your specific case if you have that. Yeah, perfect, Dmitry.
Thank you. It was a pleasure for me to spend with time. Do we have also some questions, or let's?
Yeah. We just read a bunch of questions from the chat. I mean, all of the questions are from the chat that we have taken. Perfect. For more questions, guys, we will of course be in the forum. We are in Discord. You should join that. So yeah, on that note, thanks a lot, Dmitry, and thanks a lot everyone who's been watching us. We'll see each other soon. And this week we still have, I think we have one more workshop that's with Unity SDK. So we've had React Native, we've had React, Unity. I think it's later this week, but you can check your calendar, which you get from the hackathon website, and see you in Discord and forums. Thanks, guys.
Yeah,
we'll be in touch. Yeah.
Yeah, the Unity workshop will be in 2 days.
Perfect.
Yeah, thank you. It was a pleasure for me to spend this time with you all, guys. Let's build and build it with Moralis.
Okay, thank you, Dmitry. I do think React is a very powerful tool, and Moralis just provided this very useful toolkit for developers to get started with React.
Yeah.
So do remember, React make it painless to create interactive UIs. Design is pretty simple for each state in the application, and React will efficiently update and render just the right components when your data changes. Okay, I think that's all for tonight's session. And speaking about our next workshop, the same time next week, Wenjia, would you share a little more on the next workshop topics?
The next topic, I think it will be Gamefi, right?
Yeah, exactly. So I'm
you are a crazy
know nothing
fan
about
of
Gamefi, but I think you are the expert of Gamefi.
No, I'm
so
just
it's your turn next time.
Expert of the game, not Gamefi.
Yeah, game first, then Gamefi, then token.
Yeah, of course. We already have so much excellent game on our ecosystem, I think. So it's our honor to invite them to join us in our workshop.
Yeah, do you have the name for the Gamefi project next week?
I think maybe a little secret.
Okay.
Guys,
okay.
You can find the answer on our social media.
Sure. I think we are a little over time tonight, so maybe we just say goodbye to our audience and stay tuned with us for the next workshop of Avalanche Hackathon Asia.
Yeah. So, okay. Take care, Lini. Bye-bye. See you next week.
Take care, guys, folks. Bye.